So do you have like a corporate venture program, or do you invest in startup?
We do invest in startups, but more like a handful of companies. There's nobody at Corning whose job is focused on corporate venturing. We tend to invest in startups when we believe that they either are in the early days or could become a large user of our glass. So some of the startups we're invested in include View. It could use our large flat glass. In this case, the same glass that you would use for displays to be used in architecture. And that's really exciting for us because the commercial market for Windows is 5 times as big as the entire display glass industry, and the residential market for Windows is as big as that. So that's, if you think about Corning at a very macro strategy level, that we're a leader in glass, but the biggest market we participate in is the 4th largest glass market. So there's a lot of room for us to go for the other 3. Another one we're doing is a company called 9 Point Medical Systems that's using fiber optics in a novel way as a diagnostic for a precursor to cancer. I mentioned the company that we're invested in that does the ceramic membrane for rechargeable batteries. And then we're invested in a company that's using our glass for high-powered semiconductors because glass is such a good insulator. And that one actually is processed using the laser that I mentioned earlier. So you guys got a new insight out of the answer to that question.
Hello.
Hi.
Well, as a Chief Strategy Officer of Corning, what would you recommend for the researchers who have ideas or invented some innovative, cool technology or like materials, but they don't know how to commercialize it or they don't know how to apply it for the market?
Yeah, our experience is that no problem. Our experience is that finding a committed customer is the most important thing that can happen for gaining adoption of the material. So I guess my advice would be to think broadly and hard about the industries that have a need that is uniquely met by the new material, and seek out the leading customers in that who would benefit most from that innovation and try to connect with them. Good. Oh, sure. I'm coming back to this side.
Yeah, I just want to know, like, what's the failure research rate in the company, and how do you deal with the failure?
Sure. So, it depends. The failure rate of R&D projects depends a lot on the nature of the project itself. So, if I'm going to give you, 2 ways to group types of projects. One way is it a cost savings opportunity for us, or is it launching a new product? If it's a cost savings opportunity for us, for example, if you're a glass maker, in general, the number one thing that you can do to bring down your costs is turn up the speed. So if you can make glass for televisions twice as fast, you only need half as much capital investment. And we're a very capital-intensive company. In fact, if you look at capital expenditures as a percentage of sales, if you look at the top 100 companies in the US, you see a bunch of utilities who are building power plants, you see Intel, and you see us. And that's the top 100. We are way up there. In fact, for our LCD glass business, we own over $3 billion worth of platinum. That is all a capital investment we have to make. To build a new fab to make Gen 10.5 glass, which is the glass that's twice as big as a king-size bed and you would want to use for making the largest televisions, that investment is between $1.5 and $2 billion. So if you can turn up the speed and get twice as much out of it, that's a really big deal. Those types have a very high success rate because you control everything about them. They may not get done quite as well as you want. You may not capture all the benefit that you think. On the other hand, you may look at it and realize that there are tremendous other benefits to go. An example of what we can do is if you look at optical fiber, we invented the manufacturing process 45 years ago. It probably took us almost 10 years to get the first big commercial customer. But in terms of cost of manufacturing, we've reduced the cost by a factor of 2 in the last decade. So those, we probably invest a third of our R&D budget into new ways to manufacture that may give us new capabilities, but probably also make it cheaper for us to manufacture the product. Very high success rate on those. So the other category would be now we're trying to invent a new product. That's much harder. Our observation is if we are using capabilities that we already have, either in terms of core science technologies or the manufacturing and engineering platforms, it's much cheaper. We're going to have a higher probability of success. But there's no guarantee when you do that. But it goes way up if you have those things. So those are the types of things that I would look at. It's why we try to keep ourselves focused on sticking with opportunities that utilize at least 2 of the 3 columns of our core technologies, 4 manufacturing and engineering platforms, and 5 market access platforms. But we try to make minimally sufficient prototypes so that we can get feedback quickly. We don't worry about how you manufacture those, whether it's going to be the final way or not. Sometimes printing stuff on an inkjet printer on a piece of paper is all that you need to get somebody to understand what you're trying to do. So we're very agnostic to that. We have certain programs that we put, like 5 or 6 programs that we think have very high potential, but are not within directly any of our existing businesses. We put them under our Chief Innovation Officer, whose sole job is to help those cross the chasm from the lab into the commercial marketplace. So we have lots of management processes in place, but those are all designed to recognize that the failure rate is significant and to maximize the opportunity that we do succeed, but if we're not, to recognize that early and stop it. But having said that, the hardest thing to do at Corning is to stop a project that people are passionate about.
How do you position Corning glass in this age of 3D printing, where everyone can, do the rapid prototyping?
Well, first, we are a huge user of 3D printing and have extended the capabilities of commercial products to do 3D printing for ourselves. Because very little of, we had the CTO of a leading integrated circuit manufacturer in our labs. And he's walking around, he's like, this equipment is amazing, where do you buy it? And our CTO says, we make it. And the semiconductor CTO says, oh, I get why you guys are very profitable. So when you manufacture those, it's often very low volume that you need to build 10 machines or something like that. So we actually use 3D printing to make components that we use in our manufacturing processes. And some of the reasons that we can control our products so well and are innovating faster is because 3D printing lets us do that more quickly. Another way to look at it is, and it lets us make prototypes that we can interact with a customer with quite fast. Even if it's not in the material we'll use at the end, getting your hands on something and experience it really creates ownership from the potential customer. You get much better feedback. So we use it in those ways all the time. I think in terms of like the range of 3D printing technologies that we use, how we do them, how we've taken apart the machines and built them to be better than the original manufacturer did, I think we're actually pretty distinctive in some of the things that we have done. There's another opportunity, which is to actually 3D print glass objects yourself. I would argue that the way we make fiber optics is in a way a 3D printer. Most glass objects, you start with sand, you melt the sand, you put some stuff in, and you have glass. With fiber optics to get the purity you need for the kind of transmission that I talked about earlier today, we actually start with the gases and form a solid. So, you know, it's a fairly ugly solid that we then process in a lot of different ways, but we do it. You can make your own 3D printer of glass. There's a great YouTube video where a student took lenses out into a desert and then focused the sun and melted the underlying sand and makes a bowl. I think it's a very cool example of 3D printing at a low price. The problem with glass is to get the look and feel and handling of light and introduction of color, you need extremely high temperatures and certain melting conditions that people so far haven't found a good way to 3D print. The 3D printers of glass that are in public today basically have a crucible where you melt the glass with a hole in the bottom, and then you either move the crucible or you move what's underneath it, and you move them to create the form. They look really cool, but I don't think there's any potential to make an object that you couldn't make in a better way using an alternative technique. Nevertheless, you might guess that this is an exciting area, so of course Corning is doing research on using and developing some other techniques to 3D print glass, but it's still pretty early days on those. But I think 3D printing, certainly in terms of its impact on us, has been huge. And we have one other way to use it that we're just installing the printer right now. So, you know, a very active area for us. We have a whole department that does 3D printing. Good. Well, I really appreciate all of you being here. I think we've already gone over time a bit. I wish you the best in your studies at the program. And oh, you're going to have one more question? You could come up afterwards and ask me. I'm sensitive to the time. Ed, we'll do that. I'm sensitive to the time. I'm a punctual person.
All right. Thank you, Jeff. Thank you so much, and thank you everyone for coming today for the IDE talk. We have a series of talks where we invite innovators and people who are great example of the concept of see different, think big, act small. And last but not least, our professor, Ajahn Ed, the program director of IDE Center, would like to wrap up this event.
Better sit down, Jeff. This is going to take some time.
All right. Maybe I'll just stand against the wall.
Yeah. So thanks. I wanted to make a couple of comments. We got you locked in the room, and I want to tell you a little bit about why we do these things. So, or why I hope you can get something out of it, no matter what your background is. All right. So first of all, I'm a believer, and this is the reason we do these talks. I'm a believer that just hearing a new idea, even if it's not in your business or your domain or wherever you're working, that there's a possibility of when you hear new ideas to open your mind to new opportunities. So for example, you know, most of you in the room have crossed paths with me one way or another, and there's one gang here which is called the STI Fellows Program. Okay, we work on this Fellows Program. So I was interested to hear about the Corning Fellows Program and how that if you achieve something, you become a Corning Fellow. And I thought it was cool that you become a Corning Fellow for life. And then the most insightful thing, which if you're going to have people be Corning Fellows for life, choose people who are 90 years old. I think that's a very clever. Oh, okay, I misunderstood that part.
We have a life cycle. Probably our youngest fellow is about 40.
Okay, 40. Okay, so he's got 50 years to go. Okay.
Yeah, exactly. We hope.
We hope, yeah. He hopes as well.
But that's our goal, is to make it exciting for him to stick around for another 50 years.
Yeah, great. Yeah. So I mean, when I hear someone talk in any area, I like, you know, it begins to kind of set some crazy ideas. But since we're here, I wanted to talk a little bit about our three letters here, IDE. You know, I is obviously innovation. And so one of the things that's interesting about Jeff's talk, which is a little bit different than other talks that we've had that you've heard, is Jeff brings a perspective of a bigger established company where, you know, we put a lot of focus on the E part. And one of the things that I wanted to add a couple things that Jeff was telling us earlier before we came here. So one of the, can you put up master picks? The master picks? You're trying, okay. So one of the companies that Jeff was showing us downstairs is a company called Masterpix. You could look it up on your phone, maybe. But basically, it's using, is that Gorilla Glass that's in the? Gorilla Glass. Okay, so it's the very durable glass. But what the company does is you send a photo to the company, they print it on the glass, so it's a very, very durable photo on glass. Well, Masterpix, I'm assuming, is a really small company. I'm right. It's a entrepreneurial startup, and the technology involved, according to Jeff, is basically an inkjet process, right? So I mean, it's even something you could start here, right? You could start here and get something. So the thing is, the opportunities we're talking about aren't necessarily deep science. They're really just an opportunity to keep looking at different ways of using things, and that's really what we try to emphasize with IDE. So thinking bigger. So the real thing behind IDE, innovation-driven entrepreneurship, is the entrepreneurial part, but really the idea of thinking bigger about what we do. So that's kind of the second message I want to leave you with. The third message, which you've all heard, anyone who's spent any time with me, unfortunately, like these guys have, is innovation comes from having weird ideas that come together from different places. So one of our goals for this talk is to bring all of you together from different backgrounds, which doesn't happen very often, okay? So we've got researchers in the room, so we've got a chunk of researchers in the room. We even have a celebrity researcher, Weeboon, our celebrity researcher. Okay? I knew him when he was a researcher, but he's more celebrity these days, okay? But we have adjuncts and professors in the room. We have people from companies in the room, big companies and startup companies, and we hope these talks are also ways to bring people together and start chit-chatting, because that's really the way to get new ideas. So we have these every month. We're not having one in April because of Songkran, but we hope to see you again here in May. We'll get it assigned to you. We'll tell you what's going on and get a date out to you in the next week or two. That's not true, and it'll be about 3 weeks, sorry. But please come by on a regular basis and continue these conversations. If you learn something about glass, great. But if you also just learn something inspiring about innovation, that was our main goal today. And finally, the other main reason we had this talk is because I've known Jeff since I was 13. We were 13. So thanks a lot for coming to Thailand and having done this for us. My pleasure. Thank you. Thanks, everyone.